All right, as you can tell, I'm not here today. You have 5 minutes to do your warm up. Once that 5 minutes is up, I will go over the warm ups with you. Here we go. All right, time's up. Let's look at number one. It says store manager begins each shift with the same total amount of money. She keeps $200 in a safe and distributes the rest equally to the five cashiers in the store. This situation can be represented by the function y equals x minus 200 divided by 5. What does the x represent in this situation? A says the total amount of money in the manager has at the beginning of the shift. Let's see, a store manager begins each shift with the same total amount of money. So I think A is the most proper answer. So A is your answer. We don't have to go any further. All right, number two, you can buy used ice skates from an online website for $40, or you can rent some at the ice rink for $2 an hour. Either option still requires you to rent safety equipment for $1.50 per hour. How many hours must you ice skate for the cost of renting or buying to be the same? So you buy them online. You got You're gonna pay $40, and then you got to plus you got to pay $1.50 an hour for safety equipment. If you rent everything at the ice rink, you got to pay $2 an hour and $1.50 an hour for equipment and safety equipment. So that's $3.50 per hour. All right, so there's our equation. First thing we're going to do is subtract 1.5x from both sides. Left with 40 equals 2x. Divide both sides by 2. And x equals 20. So it would take 20 hours for it to be the same price. All right, trade homework. Pass it to the person behind you and get ready to grade homework. You have about 2 minutes. Let's make that a minute. All right, 30 seconds. All right, here we go. On the first page, you had to draw on 1 and 2, you had to draw the reflection. If they didn't put their labels, it's 2 points for the labels, 2 points for not connecting the lines. Otherwise, if they didn't do it right, it's just an X. So that's 1 and 2 on the front. On the back of that page, at the top, 1 through 3, those are your answers. I'll give you just a minute to look over those. All right, and those would be just 1X each. All right, on that page, continuing, on the bottom there, you have 4 and 5. You just had to draw the pictures. You had to label them and connect the dots. Same as 2 points each on those as well if they did not put the label or connect with dots. On 6, A, B, and C, each one is an X. If the drawings are not in the right spot, it is wrong. Give you just a second to look over this one. All right, and on the last page, on number 1 and 2, you had to draw the picture or the reflection and describe how it reflected. So It's an X for the drawing. It's 1X for the description. So that's 2 X's on each one of these problems. 1 through 4, all 4 problems is 1X per problem. Okay, each problem or each X is worth 5 points. Count out how many X's and then subtract it from 100 and put a grade on it. Once you've put a grade on it, give it back to them. Once you've seen your paper, pass it to the front. We'll answer any questions tomorrow. You have 1 minute to get this done. Go. Once you've passed your paper up, you should have your notes out and ready to go. Got about 30 more seconds to get everything passed up. If you weren't able to grade something, you can talk to me about it tomorrow. We'll fix it tomorrow. Just get it all passed up. You got 10 seconds. All right, 5 seconds. Everything should be taken up. Go to the first page of the notes. All right, 12.3, rotations. Rotation is a transformation that turns a figure around a given point called the center of rotation. The image has the same size and shape as the pre-image. So nothing's changing shape or size. It's just changing where it is on the coordinate plane, just as it was in reflections and translations. So the images are congruent. Rotations can be clockwise or counterclockwise. That's clockwise is to the right and counterclockwise is to the left. I will abbreviate clockwise as CW and counterclockwise as CCW. All right. Each quadrant on the coordinate plane is 90 degrees. As you see, that is a 90-degree angle in every one of those. The rotations we will use are 90 or 1/4 turn, 180 is 2/4 turns, 270 is 3/4 turns, and 360 is 4/4 turns. Okay. If you don't remember the quadrants, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, moving on. All right, so we're looking at this. It says A is the pre-image. That's the original. Pre-image is the original. All right. It says which triangle is a 90-degree rotation clockwise. So if I start here in A, all right, in quadrant 2, and I want to rotate clockwise. Clockwise is to the right. Okay, and I want to go 90 degrees. Every 90 degrees is going over one quadrant. So if I'm in 2 and I go 90 degrees clockwise, I am now in quadrant 1. Okay, if I go 90 degrees counterclockwise, that means I'm going to go left. That means I am going to go down 90 degrees. That's one quadrant, and I am in quadrant 3. And A is in quadrant 2. All right, describe the rotation from A to C. Okay, if I go 90, 180, I can say it's 180 degrees clockwise, or I could say it's 180 degrees counterclockwise. Okay, 180 degrees either direction will put you in the same spot. All right, describe the rotation from A to D in 2 ways. So if I go from A to D like I did the first time, as I did here, that would be 90 degree counterclockwise. And what if I go the other direction? What if I go right? How many degrees did I go that way? Count it. 90, that's 1. 2, that's 180. 3 is 270. So that is 270 degrees clockwise. Okay? All right, moving on. I know this is kind of fast, but just bear with me. We'll review on it tomorrow as well. Triangle ABC, here's our triangle ABC, is rotated. Identify which quadrant each image would land in. So, if I rotated this 90 degrees clockwise, counterclockwise, so I went to the left, 90 degrees. 90 degrees, that's one quadrant over. What quadrant would that be in? 2. This is 1, 2, 3, 4. All right, what if I go 180 in any direction? I go 180 counter, I end up in 3. If I go 180 clockwise, I end up in 3. So no matter what, I end up in quadrant 3. What about 270 clockwise? That means I'm going to go 3 quadrants. Okay, so clockwise would be to the right, or in this case, I'm going down. So 1, 2, 3. That puts me in quadrant 2. Any 360-degree rotation, clockwise or counterclockwise, is going to put you right back where you start. So that puts us back in 1. All right. Next is where it kind of gets a little difficult. I'm going to show you how to draw a rotation. And these are the instructions to do so. So if you get confused, come back to these instructions and read through them carefully. All right. The first thing that we're going to do is we're going to choose one point on the pre-image to start with. Okay, so I would start, if I start with, that means I'm starting with 1 point right there. Let's say I'm starting right here. Okay, you can see how many spaces over and up you have to move from the origin to land on the point. So what are the coordinates of that point? 2, 2. All right, so my coordinates are 2, 2 here. All right, next you're going to actually pick up your paper and turn it the same number of rotations to match how many degrees your shape is going to rotate. So if you want to rotate 90 degrees, you're going to turn it 1/4 turn. And I'm going to show you that on the example here in just a second. If you want to go 180, you're going to turn it twice. 3 times for 270 and 4 times. Now, you must turn your paper the opposite direction that you want to rotate the shape. So if you're doing a clockwise rotation, you're going to rotate your paper counterclockwise. All right, so if you're going to do a counterclockwise, you're going to rotate your paper clockwise. All right, and then you're going to draw an arrow above your graph to show which direction the rotation will go. All right, this will make it easier to see which way the paper, turn your paper in the opposite arrow you drew. All right, so this is when you turn your paper back. When you turn your paper, so basically it says if you want to go clockwise, point an arrow that way, so you know to turn your paper that way. So because you want your rotation to be to the right or clockwise. All right, then once you get it all turned the way it's supposed to be, we're going to plot the new point. Okay, by going over and up the same amount of spaces as we took in our first coordinate. So I'm going to show you an example here. Go to this, not this page. Let's go to the next one. Sorry. All right, so I have A, B, C, D here. All right, it wants me to graph this quadrilateral 180 degrees. So what I'm going to do is I know I need to go 180 degrees. It doesn't matter which way I go 180 degrees. It's just 180 degrees. So I can turn it right or I can rotate it left. It doesn't matter. Let's say we're going to go 180 clockwise. Okay, so that means I need to turn my paper that way. So take your paper, and you're going to turn it, pick it up, and turn it twice. So this is what twice would be. 1, 2. So it's basically upside down. Okay. Now the thing we didn't do was select a point. So we need to select a point first. We don't want to do A because A is going to be in the same spot. Let's pick B. And it's best to go ahead and write these down. So B, B is at what? 1, 2. C is at 4, 2. And D is at 3, 0. Okay. And so now we're going to rotate our paper 180 degrees. 90, 180. Now, this is the orientation of our coordinate now, our coordinate plane. Now we're going to use these points and graph it. So here's A. It's not gonna change. Okay, so there's A prime now. So A prime. Now B is at 1, 2. So we're gonna start just like this is our origin. 1, 2. We do 4, 2. 1, 2, 3, 4. 1, 2. And then we're gonna do 3, 0. 1, 2, 3, 0. So B. So this is B prime. This is C prime. And this is D prime. Then we connect your dots straight as I can. And we have now rotated that drawing 180 degrees. So now we're going to turn our paper back. Oh, I gotta do this first. Oops. All right, so now I can turn my paper back. All right. And I know my letters are upside down, but I have now rotated that picture 180 degrees. All right, so let's do this next one, 270 degrees clockwise. All right, so 270 degrees clockwise means I need to turn my paper counterclockwise. Again, all right, we're doing clockwise 180, so this clockwise 270. This time 270 is 3 turns. Okay, 90, 180, 270. That's 3 turns. So I'm going to turn my paper counterclockwise 3 times. 1, 2, 3. Okay, and then I'm going to plot these points again. So we go 1, 2 for B, 1, 2 for B. So that's B prime. 4, 2, 1, 2, 3, 4, 1, 2 for C prime. And then 1, 2, 3, 0 for D prime. Connect our dots. Okay. Group this together. And now I can turn my paper back to the original direction. Now I have a 180 and a 270 clockwise. Okay. All right. Next it says find the coordinates of point C after a 90 degrees counterclockwise rotation followed by a 180. So that wants us to rotate twice, 190 and then 180. So let's look at that. 90 counterclockwise, that means we would turn our paper 1 time this way and then 180. So that means upside down. All right, so that means that this is where I will need to put my points. Okay, I'll do it again. Started here. We're going to go 90 counterclockwise, so I need to go 90 clockwise, and then 180. So that would be 1, 2. So let's 1, 2. Try it again. 90 counterclockwise, so we put 90 clockwise. go 180. 1, 2, yeah, that's right. So it would be right back where we were starting. Okay. So that would be right back where we started. So C is at 4T, just like it is here. All right, let's do a couple more. All right, draw the image of the figure after the given rotation about the origin. So we're going to do it 90 degrees counterclockwise. So that's 90 degrees counterclockwise. So first I need to use what are my points? All right, E 0 0, F is 1 2 3 0, and G is 0 negative 3. Okay. Now I have my points. I need to go counterclockwise, so that means I'm turning my paper clockwise one time. And then I want to plot those points. 0 2. I'm sorry, E is 0 0, so right there. And then 3 0 and 0 negative 3. F prime, G prime. All right. These together. Rotate them back. Rotate it back this way. And there is what a 90 degree counterclockwise looks like. All right. All right. We're going to skip that one just for time's sake. Let's look at this one. The figure shows triangle ABC and a rotation of the triangle about the origin. How would you describe the rotation? So it started here. So it starts at, I would pick one point. It's at 1, 2, 3. B is at 3, 2. So B is at 3, 2. Okay, B prime. Let's see what we have to rotate that to get that to be at 3, 2. So if we go counterclockwise, that's not going to make 3, 2. Not going to make 3, 2. Sorry, and that's negative 2. So there's 3 negative 2. All right, that was 3 negative 2. So how many times? What do we have to turn that? We had to turn that. Let's go back. Counterclockwise, we had to go 1, 2, 3. So that would be counterclockwise 270, but there's always two different types. So let's go back the other direction. So if I go 270 counterclockwise, so I'm sorry, that would be clockwise. So I had to go turn. Since I turned my paper counter, that means it was a clockwise rotation. Okay. Now let's turn my paper clockwise, which would be a counterclockwise rotation. I know this is confusing. 1. Okay, so that's 90 degrees counterclockwise. So, or 90 degrees counterclockwise. All right. All right. What are the coordinates? Well, that's simple. Let's go to the next one just for time's sake again. What type of rotation will preserve the orientation of the H shape figured in the grid? So what kind of orientation or what kind of rotation will put it back to make it look the same? Okay. Wouldn't it just be 180 degrees? Couldn't we just rotate that 180 degrees and it would look exactly the same? Okay. 180 degrees. All right. A point with coordinates -2, -3 is rotated 90 degrees clockwise about the origin. What are the coordinates of its image? All right, so this is where we start getting into the algebraic stuff. So the algebraic representation for a 90-degree clockwise, it's going to look like this. And instead of being XY, it puts the Y to the front and the X to the back, and changes the X to its opposite. So that means our XY is going to be, we'll put our Y up front, that's -3, and change our X to its opposite. That would be +2. So that would be the new coordinates if we rotated 90 degrees clockwise. All right, let's get into more algebraic stuff. All right, let's complete the table with rotations of 180 degrees or less. Include the directions of rotations for rotations less than 180 degrees. All right, so I went ahead and filled this out. So copy this down real quick. It says shape is in quadrant 1, and you go 180 degrees. It's now on 4, so that's either a 9. So if I go from 1 to 4, that means I did either 90 degrees clockwise or I did a 270 counter. So that's saying if I started here and I ended up here, those are the 2 rotations that I could have made. I started in 3, end up 1, that means I did 180. I started in 4, end up in 3, that means I did either 90 clockwise or 270 counter. All right, should have that down by now. All right, so here are the algebraic representations for rotations. All right, 90 degrees clockwise is the same as a 270 degree counterclockwise. So what you do is you flip the X and the Y and change the X to its opposite. Right, I know these are confusing. You need to memorize these for the test because you will not have this on a formula sheet. These are something you need to memorize even for STAR. All right, 90 counterclockwise. You're going to flip the X and the Y and make the Y the opposite. So 90 clockwise and 90 counterclockwise, which are 270 counter and 270 clock, are basically the same except for which coordinate is changed to its opposite. So clockwise, it changes X to its opposite, and counter changes the Y to its opposite. And then on a 180 degree rotation, you just take the coordinate and you change both to their opposites. All right, so let's do a little practice. 5, -8 for 90 degrees clockwise. So that says 90 degrees clockwise says we need to flip them and change the X to its opposite. So flipped, that means -8 will come first, and I need to change 5 to its opposite. So I did 90 counterclockwise, that means I'm still flipping. I'm going to change Y to its opposite. So now 8 becomes positive, and 5 stays the same. For 180, I just changed both of them to their opposite. So -5, +8. Number 2, 90 counterclockwise. I'm going to switch them and change the Y to its opposite. So Y is -15, it's going to become +15 and move to the front, leave X the same. 180, I'm going to change both of them to their opposite, so that's just 11, 15. And then 90 clockwise, flip them, X becomes its opposite. So flip, -15 stays, -11 becomes +11. And for the last one, 270 clockwise becomes 270 clockwise. We're going to flip, keep Y the same, change X to its opposite. So 13 and -21. 180, that just makes them both change to their opposite. So that'd be -21, -13. 270 counterclockwise. Oh, I'm sorry, this was 270 clockwise. I did this one wrong. This one's going to change the y to its opposite, so that's negative 13 and 21. This one is 13 and negative 21. All right, I had those backwards. All right, now back page. So the back page, this wants us to write the transformation rule algebraically, then describe it. So I find that's easier. Let's describe it first. What happened first? We started here. We're in quadrant 3. We ended up in 1. Okay. The easiest I would say is 90 degrees counterclockwise. So 90 counterclockwise. So what is our rule for 90 degrees counterclockwise? Well, that's going to be X, Y, and then our little arrow, and then there was the flip the X and the Y, and for counter, we're changing our Y to its opposite. So there's our algebraic rule. All right, number 2, we're going from quadrant 4 to 1. I got that all kinds of backwards. 4 to 1, there we go. We went from 4 to 1. It looks like I would call that 90 counterclockwise. Sorry, this was counterclockwise. No, I'm sorry, that went down. So that was counterclockwise. This went counterclockwise as well. Okay, so that's the same rule. Negative y, x. Okay. Now we got 2 more problems and we'll be done with this long video. All right, 3 looks like it wants us to draw this one. This says use the given rule to graph the image and then describe the transformation. All right, this should be negative. So it's just a negative y comma x. So negative y x. That means we're doing a 90-degree counter clockwise. Okay. So our points are 1 0. Excuse me. Yeah, 1 0. 1 negative 4. And 3 negative 4. I think we'll just do this one because we're running out of time. All right, so I need to take this. I want to do a 90-degree clockwise. So I need to go 90, turn my paper counterclockwise. So 90 degrees counterclockwise. All right, and then I'm going to put my points 1 0, 1 0, 1 negative 4, and 3 negative 4. Connect my dots. Combine this together. Oops. Do that. I don't know if it's going to make this off. Now we can put it together and turn it back. And that. I turned my deal the wrong way, didn't I? So this is where it was. So I need to turn one time to counter. Let's try something different. Let's go ahead and do this real quick. let's undo the flip. We're not gonna do the flip paper. Let's just change our coordinates. All right, so let's change this to -1, 0. That's not right because it's going to be 0, 1. Excuse me, because we got to flip. 0 can't be negative. All right, 4 is going to be here, but it's going to be positive now. 1. 4 is going to be here, but positive now, and 3. So let's 0, 1. Flip this back in. So 0, 1, 4, 1, 4, 3. 0, 1. All right. So there is our 90 clockwise. That doesn't seem right. That is 90 counterclockwise. Yeah, that's why I missed it. It wouldn't work for me. This is supposed to be counterclockwise. I know it's confusing. All right, guys, we'll go back over this and refresh tomorrow. Do your homework, do the best you can. I'll let you ask questions for the first couple minutes of class tomorrow. Good luck. Have a good day.